Hello students, this is Professor Chalai. This week we're going to look at chapter 5, Thermochemistry. Now thermo comes from the Greek word meaning hot or heat. And so as you would suspect, this chapter is all about the heat transfers that occur when we do chemistry in chemical reactions. As always, you can follow along with our chapter 5 workbook. And specifically for this lecture, we're going to look at the energy basics and more specifically, the units of energy. And so by the end of this video, you should be able to convert between the different energy units. Now, before I get to that, there's some definitions here for energy, kinetic energy, potential energy, and chemical energy that I'd like you to fill by yourself by reading our online textbook. If you have questions about those, please let me know. But after you understand the different kinds of energies that exist, let's look at the different kinds of units that we use to express energy. Now the joule, represented by a J, so Joule, or capital J, is the SI unit for energy. So the SI unit for energy. So typically, whenever we're performing calculations, we might want to convert energy from whatever units we have into joules. Joule is a derived unit, similar to how density is a derived unit. That's actually the mass over the volume. Joule is a derived unit that comes from the mass times the length square divided by time square, or sometimes Newton times meters. But those are all equivalent. 1 joule is the same as 1 kilogram times meter squared divided by second square, or it's the same as 1 Newton times meters. Newton is the SI unit for force, which we won't focus a lot on in chemistry, but you might have heard of it from physics courses. So the joule is the unit, the SI unit for energy, but you might have heard of other units for energy used commonly, such as the calorie, right, which is 4.184 joules exactly. Exactly here means that this is the infinite number of sig figs if when we're converting units. More commonly, what you might have heard of is the food calorie. This is the calorie that you see on food products that you might consume. They're actually food calorie, which is not the same as a regular scientific calorie. And the units are slightly different too. So the scientific calorie is lowercase cal, and the food calorie is uppercase cal. So make sure we recognize those differences. The food calorie is exactly 1,000 regular calories. So one food calorie is 1,000 regular calorie. Or you can write it as one big cal is equal to 1,000 little cal. So that means that one food calorie is 4,184 joules exactly. Again, that's the infinite number of sig figs. And then another unit of energy that you might have heard of is a kilowatt hour. So kilowatt is just 1,000 watts times the amount of time that the appliance has been running for, gives us the kilowatt hour. And this is what you would have seen if you look at your electricity bill, for example, the amount of kilowatt hours of energy that your house uses over a month in the monthly bill. And so 1 kilowatt hour is exactly equal to 3.6 by 10 to the 6 joules. Again, the infinite number of sig figs for conversion purposes and significant figures. So now that we have all of these, you should be able to convert from each of these units into another easily using the same set of rules that we've been using. But to practice doing that, let's look at number 1. And I would like you to pause the video here and try number 1 on your own, and then unpause the video and we'll go over it together. But number 1 asks, what consumes more energy? A person eating 2,000 calories per day, so that's food calories, right? Capital CAL, which is the typical suggested diet, or a 100 watt light bulb running for 24 hours. So a 100 watt light bulb, some of you might know, is the brighter old-timey incandescent light bulbs that people may have had in their homes. So which one consumes more energy? The question asks us to convert both to joules to determine the answer. So let's focus on them one at a time. Let's focus on a person eating 2,000 calories per day. So that's a person eating 2,000 food calories, so that's capital CAL. And the conversion here says that one food calorie is 4184 joules. So 1 food calorie is 4184 joules. So calories cancel out, and you plug this into your calculator, you should get 8368000 joules, or to one significant figure, this becomes 8 by 10 to the 6, or 8 million joules. So if you burn 2,000 calories a day, that's 8 million joules you're burning. Let's look at the second situation. Let's look at a light bulb left running, a 100 watt light bulb left running for 24 hours. So it's a bulb, it's 100 watts, right? Big W, times 24H hours. So that gives us the energy. Here it gives us kilowatt hours to joules. So we need this in kilowatts instead of watts. So let's convert to kilowatts. We know that 1 kilo means 1,000, so 1,000 watts is 1 kilowatt. And so now we have kilowatt times hours, which is this unit right there. So now let's convert kilowatt hour. We know that 1 kilowatt hour is the same as 3.6 by 10 to the 6 joules, right? So that will give us an answer of, let's use red, 8640000 joules. We round this up to one significant figure, right? Because we start with 100 watts. That gives us about 9 by 10 to the 6 joules, or around 9 million joules. So the answer is the light bulb. The light bulb consumes more energy, but not by a lot, right? Like this number is not very a lot different from this number. So there it is. A person consuming about 2,000 calories a day burns as much energy as a 100 watt light bulb running for the same amount of time. Alright, that'll bring us to the end of this video. Hopefully by the end you understand that there are different units of energy and you're able to convert between any one of those units of energy. And I want to point out again that food calorie is big CAL and it's 1,000 times the regular calorie. Alright, I'll see you in the next video when we go over thermal energy, temperature, and heat. I'll see you then. Bye.